Okay, welcome to this webinar, where we introduce you our wonderful project, Precilience. My name is Petteri Karisto. I am a research scientist at the Natural Resources Institute Finland and the coordinator to Precilience. We are here today to tell you all about how we are implementing science in practice to help food and forest production to adapt to changing climate, with a massive 10 million euros funding from EU. If you have any questions during the webinar, please write them down in the chat so that we can answer them at the end. Let's start with the goals of our project. So, first of all, our project and us, we belong to the EU mission on adaptation to climate change. These missions are tools for EU to put policy into practice. Hence, our job is to support climate adaptation. That is, to make our fields and forests durable. We achieve that by helping the people who are doing that. For example, farmers, forest owners, companies related to those actions and sectors, and regional authorities. Further, the mission has a strong regional approach, as all the changes that we observe are happening in the particular conditions and context of every region. Our work is focusing on these 5 northern countries: Finland, Estonia, Sweden, Norway, and Denmark, and specifically on 11 regions within those countries. So these are our goals, and how are we going to achieve those? How do we support adaptation? Our answer is precision resilience, or longer, precise solutions for resilience. Resilience means ability to survive, adapt, and bounce back in new conditions. As we all know, climate changes, but what does that mean in practice, in your life, in your conditions? It brings new risks, but also possibilities, and we need practical solutions for both of those. So together with stakeholders in our focal regions, we will create knowledge on the practical, most relevant impacts, both risks and possibilities, in the everyday life, and practical, most suitable solutions. This is the precision. Then we will put this knowledge and solutions into work in various demonstrations where we aim to show how to apply them and demonstrate their suitability in practice. In summary, we aim to provide those regions with best knowledge and tools and put these solutions in work, all in tight collaboration with the everyday experts of those regions. So, who is going to do this? Let's have a look. Our project team comprises of 16 partner organizations. These are funded directly by EU. In addition to these, we have several others who work on the project, for example, as subcontractors or via other kind of collaboration. The biggest partners in each country are highlighted now on the slide. Natural Resources Institute of Finland, Estonian University of Life Sciences, Swedish University of Agricultural Sciences, Norwegian Institute of Bioeconomy Research, and University of Aarhus. These are leading research organizations on agriculture and forestry in the area. But as already said, the stakeholders are really key to success in this project. And some example of those are Eesti Erämetsäliit, that is Estonian Private Forest Union, Østfold Fylkeskommune, that is Østfold County Council in southern Norway, and Seges Innovation, an independent research and innovation company in Denmark. And finally, of course, you in the audience, you also have a chance to be involved with the project. With this said, welcome once more, and let's hear more details from the next 5 presenters who will explain more practically what we are doing in the project. We start with Mikko Peltoniemi from the Natural Resources Institute Finland. Mikko, floor is yours. Please unmute yourself.
Thank you, Petteri. So, yes, my name is Mikko Peltoniemi, and I'm working as a research professor at the Natural Resources Institute Finland, LUKE. So, today I'm going to talk about local risks and opportunities for crop and forest production and how we are working with them in Precilience. Okay, next slide. The goal of this work package is to co-create climate impact and risk information that supports the adaptation of agriculture and forestry in the regions. We have altogether 11 regions set up in 5 countries in the project, and we will go to detailed region-specific assessments of their future multi-risk environment. We will compile state-of-the-art knowledge on scenarios of climate change for the regions and the changes in the multi-risk environment. That means that we will identify locally relevant climate risks and impacts for the 2 sectors that we are dealing with. We are also aiming at an active dialogue with different stakeholders and communication and passing climate change impact and multi-risk information for various regional actors, particularly the landowners and authorities that support their work. In Precilience and in VP1, we are taking a bottom-up approach, meaning that we will closely listen how the stakeholders, particularly the landowners, see the climate risks for their livelihoods and sources of income. A lot will happen in future. Risk will definitely increase, and that will also call for action. So close discussion with the stakeholders doing the real action is needed. We'll be giving the stakeholders a platform where they can share their experiences and concerns about the climate change with each other and also with us. It's also an opportunity for researchers to learn about the challenges stakeholders are facing in practice. So the idea is to foster knowledge exchange between us and the landowners. What does that mean in practice? We will conduct in-depth interviews of key persons and run 11 workshops in 11 regions. We will use this information that we collect by interviews and workshops in further tasks and VPs when we are thinking about adaptation options. As an outcome, we will also create narratives, kind of like encapsulating personal experiences and expectations of stakeholders, and relate to those what we know about the expected climate change and its impacts. The scientific analysis that we will do in the project will produce knowledge about the climate change in the regions. It means that we will quantify the current and future risk for forestry and agriculture, particularly for the production in both, including water-related risks, storms, and changes in climatic suitabilities of different crops and tree species. Together with VP2, and by using its models, we will quantify expected production losses due to increased risks and also future opportunities that may arise for forestry and agriculture. This will facilitate and interact with adaptation planning done in VP2 and support also the demonstrations that will be done in other VP. Finally, we will tie these biophysical risks with the information about the socio-economic context of the regions. We feel that this is crucial as the importance of risk often depends on the local context, as do also the options for adaptation. So our approach in VP1 integrates knowledge from regions to scientific knowledge on climate change and passes that further so that it can be also applied in practice. Stakeholders will play a central role in our approach. We are exchanging with them by interviews and workshops, as mentioned, but also asking feedback later on. Overall, together with stakeholders, we will scrutinize information on climate change and information about risks and opportunities, which will eventually impact the people, societies, and livelihoods. We will gather knowledge, coming from producers, including what they feel as important and what are their expectations and prospects for the future. We are also trying to understand how this relates to the regional socio-economic context, where the risks and opportunities will eventually realize. Finally, these stakeholders will also play an important role in reiterating how we communicate our results from the project further, particularly when we formulate the narratives and climate impact and risk maps and develop decision support that will later include this risk information. So I will leave it this and thank you for this opportunity.
Thank you very much, Mikko. Next, Davide Camarano from the Aarhus University will tell us about strategies to adapt to the changing conditions. Please, Davide.
Thank you very much, Petteri. And I would highlight the work that will be done in this specific research line that is called co-design of adaptation strategies. In this particular work, the aim of the work package is to plan together with all of you stakeholders a set of solutions or tool packs that could help agriculture and forestry to adapt to current and projected climate variability and changes, and also to test the created tool pack with field work and complemented with biophysical and agronomic modeling. So the rationale for doing this work is because choosing or selecting and testing proper adaptation strategies, we can empower regions to better prepare for upcoming changes. Therefore, both practitioners and policymakers will be provided with information on how the adaptation will perform under future climate conditions, but also under current climate variability. Yeah. So, in order to make a tool pack that is more suitable for your area, we need to think about the specific areas, the specific regions. For example, the adaptation strategies has to be tailored to your soil conditions, your type of cropping system, your weather patterns, the type of policy and regulation, the tradition, and anything that decisionally happen in the specific region before scaling it up. So we're gonna test the solution if the system doesn't change, business as usual. What if, for example, an agricultural example, what if farmers do what they've been doing so far, and they will keep doing this for the next 20 years, the next 50 years, and so on? That is what we define as business as usual. So what happened in this case? And then we can test how those adaptations foster under current and projected changes. I can show you a visual. So next slide will be a visual of this concept. On the y-axis, you can imagine that there is it's an example. We can relate it to the agricultural domain, so it's easy to relate. On the y-axis, we would have crop yield, for example, whereas on the x-axis, we have two different systems. One are the current climate and the future climate. So S1, the current climate. At the moment, we are on the blue dot. What we can do, we can use biophysical modeling to evaluate the impact of climate variability on our production. But we can also evaluate the impact of climate change on the current production. So what we wanted to do, we wanted to test the adaptation. For example, the green dot in the S1 is we can answer the question, is there any value of adopting adaptation on the current climate? And we can ask the same thing in the future. If we are in the future, what is the value of choosing adaptation? What is the impact of climate change on those adaptations? So these are the fundamental questions we will ask. And in order to do that, there is a need to collaborate with the local actors and stakeholders in each particular region.
Big thanks, Davide. So now that we have heard risk and opportunities analysis, as well as adaptation strategies planning, we will next hear from Jian Liu, who comes from Norwegian Institute of Bioeconomy Research. He will speak about the practical demonstrations in agriculture.
Yes, thanks, Patrick. Yes, hello everyone. So as Patrick have introduced, my name is Jian Liu. I'm a research scientist at the Norwegian Institute of Bioeconomy Research. And NIBIO is leading for the work package 3 about testing and demonstrate transformative solutions increasing climate resilience and adaptation in agriculture. So if we put this a bit complicated title into a simple way, basically we are testing and demonstrating the solutions for producing more crops while losing less soil and nutrients and polluting less in the time of climate change. Next, please. So we are doing different activities in this work package. The first activity is about crop diversification and reduced tillage. So crop diversification basically means adding a new crop or cropping systems to the existing agricultural productions. And in the Nordic countries, there has been an increasing interest in using cover crops, which is also called catch crops by many farmers and researchers. So these crops are grown after harvesting the main crops in the field, and they are used to protect the soil from erosion and for reducing nutrient leaching. And also, it's actually also, it has a very good scenery value because it looks much better if you have a green cover in the autumn than just a bare soil. And also we are going to work on different tools that have been developed at Look in Finland, and we are using these tools in other countries as well. Next, please. The second activity is about water management. So we are exploring the solutions for improved drainage and water retention and infiltration structures. And also we are going to test and demonstrate the opening river systems in collaboration with the one municipality in Norway. And because the drainage management is very important for the areas with a lot of rainfall, like in a large area of western and central Norway, for example, and also in other regions of the Nordic countries. And this kind of water storage and infiltration structures, they can help to retain the water when there is too much runoff from the landscape. But this water may be potentially used for irrigation when the soil is too dry in the early summer or spring when the crops need more water. And for opening river systems, this can be done for reducing erosion because when the river systems are quite narrow, then it creates more soil erosion from the landscape. And also, we are going to work on solutions related to soil management, specifically about we are testing soil improvers like biochar and liming, and these chemicals, or materials, they can be added to the soil for improving soil health and improving soil structure, and again reduce erosion. And also, as I mentioned earlier, the like reduced erosion tillage is also again important for reducing erosion. Next, please. Based on the results from the first 3 activities and also the existing results from our other projects, and also, of course, the past results, so we will try to integrate the results related to crop, water, and soil management practices and their impacts on crop yield, soil health, and water quality into the work to develop a system-level educational demonstration tool. And also we are going to develop a series of fact sheets and videos. So together with the tool and the fact sheets and videos, we are hoping that we will help the farmers and also other relevant stakeholders to answer the question about what kind of under what kind of climatic and landscape conditions these management practices can work for improving crop yield and reduce the soil and nutrient losses, and what kind of conditions they don't work well. Yeah, this is what I have. Thanks.
Thank you, Jan. So let's move on to the forest side then. Jürgen Aasar from the Estonian University of Life Sciences will present the practical demonstrations on forestry. Please, Jürgen.
Yes, thank you, Petteri, and hello, everyone. So the long title of our working package is Test and Demonstrate Transformative Solutions Increasing Climate Resilience and Adaptation in Forestry. So what is it all about is that the forestry part of the project aims to test and demonstrate solutions that might enhance climate resilience and adaptability in forestry in boreal region of Europe. So we know that the climate change related risks are becoming real and evident in our forests, and so the project or the forestry part of the project aims to answer questions such as what might be the best management methods to minimize this risk, and which methods are suitable for ensuring resilient, healthy, and productive forests in a changing climate. So to address these issues, we take the already available data, analyze it, synthesize it, and of course we do practical demonstrations in Estonia, Finland, Norway, and Sweden. Yes, next please. So what are these climate-induced risks in different types of forests? So to answer this, we must understand what are these new threats caused by climate change, and second, how do different aspects or characteristics of forest ecosystem, such as species composition, age, structure, management history, and even surrounding landscape influence the susceptibility of forest damages. And as an outcome, we will introduce examples of adapting to risks and changing conditions by diversifying forest structures and maybe also avoid unsuitable practices. So the next topic is forest regeneration, as I suppose it's the most important aspect in forest management to get the new young forest growing. So the questions are, what should our forests look like in the future to be resilient, or in other words, how should we regenerate our forests? Even though we know that there is a broad agreement that we need to reduce the proportion of conifer monocultures, especially spruce, Norway spruce, and we should diversify our forest. But still, we have many questions, such as which tree species to use, how these species are susceptible to diseases, and so on. And therefore, we address the key topics in forest regeneration under a changing climate condition. And of course, another aspect in regards to forest health in changing climate is how to manage our forest. There are many questions to be answered. For example, what are the best practices for managing forests in future? Today, in our region, the clear-cut-based management is the most common management method in our region. However, we know that there is a strong political pressure to implement continuous cover forestry in larger scale than it has been done so far. However, it's not that easy because there are many risks concerning forest health and productivity related to CCF or continuous cover forestry. And are we sure that these risks are really understood and addressed in decision-making processes? Do we know how CCF impacts forest health, regeneration, and productivity in long term? So, as a practical output, we try to represent solutions and demonstrations, CCF versus rotational management or clear-cut-based management. And as a last aspect in our work package, we look for solutions for future forest health from the genetic diversity point of view. And so we ask, how does the genetic variation in Scots pine and Norway spruce influence the resilience to environmental and disease-related stresses? So we test the growth and survival and diseases of pine and spruce progenies, or may I say offsprings, which are brought from another region to another region. And these test sites are set up in Estonia and Sweden. So as an outcome, we give a practical insight into emerging diseases and the potential of assisted migration of trees from different regions as a potential method for climate adaptation. So in conclusion, our work package contributes to solutions and potential adaptation measures for the boreal forest in changing climate, so that our forests could be more healthy and productive in the future as well. So thank you.
Big thanks, Jürgen. And finally, Paloma Hannonen from Luontoa Ltd speaks about stakeholder perspectives in the project.
Thank you, Petteri. So last but not least, and actually you've heard my perspective already in all the previous presentations, all of them have mentioned the need to collaborate with the regional stakeholders and regional actors. We create regional collaboration between different scientists and different stakeholders, and also connect scientists with stakeholders. And then towards the end of the project, we also do commercialization of the Precilience products created in these different scientific projects. Next slide, please. So, bridging science and practice through stakeholder collaboration. What we are here to do is to ensure that all these projects that are science-based, and the knowledge from them are implemented into the practice with coherent processes and inclusive collaborations with regional actors and relevant stakeholders. And of course, we know that the real world is not always as fast as we hope, so we aim to find different channels to put these solutions in action. So, for example, we take into account the different socioeconomic problems or different legislations or different subsidies that might be bottlenecks for taking up of these results. We want that the outcome and that the stakeholder engagement is outcome and purpose driven. So we don't just tick a box, so to say, but we really want to collaborate with you all in the audience, if you happen to be any of the stakeholders that we want to meet. Also, we aim for stakeholders to be incorporated at all levels of the projects, in the beginning to the very end. And we will maximize the uptake of the solutions. And that's only achievable with the stakeholders taking ownerships over the different solutions. From engagement to empowerment. So here we're actually in the very first stakeholder engagement events in this webinar, and this is very one-way information outpour, so to say. We want to inform different stakeholders of the objectives of this Precilience project and the different parts of it. But then actually in the last part, and it's already partly in action, we want to consult and understand the concept in the different regions. So learning from the demonstrations and also workshops that we're going to hold about the context for change. What are the possible obstacles in different regions for the uptake of the results? Then we want to collaborate with stakeholders to co-create the best possible solutions and best possible ways for the uptake. And then we are here to empower for the uptake, creating and leveraging enabling conditions, for example, financial and technical conditions for the uptake of the results. And here is a picture of different stakeholders that are very important for the project. As you can see, they are intertwined and interlinked and not living separate lives in this world. In the core of this all is the landowners and the primary producers, farmers and forest owners. Then we have NGOs, landowner associations, local authorities and service providers. We also have, for example, forest industry and processors who are working directly with the primary producers, also retail and grocery companies and suppliers and producers. And on the outermost layer, we have national authorities and policymakers. We need to make sure that legislation is not an obstacle for the uptake of the solutions. Then we have finance and insurance sector. So we want to make sure that there is enough, for example, subsidies, that there are financial profit for the landowners in uptaking of these solutions. Next slide, please. And here you have the same image, and this is just to kind of summarize that on the right-hand side, we have all the risks that we want to understand on the regional level in both forestry and agriculture. We're going to hold interviews for the stakeholders, for farmers and foresters, and we're going to have workshops to work with the adaptations with the same stakeholder groups to kind of see what are the best ways to take up the solutions. And then on the solutions you have on the right-hand side, it starts from the direct support for landowners. But of course, if one landowner takes up a solution, it's one landowner taking up the solution. And then when you go down, read down for the list of solutions, you go, for example, in the green finance and insurance products and government support subsidies for climate adaptations. And these solutions on the bottom here might take longer to achieve, but they will affect more landowners if they are done properly. So we actually need direct work with the landowners, and then we need work with the national level and also on the EU level, so that the solutions are taken up more broadly. Next slide, please. So the stakeholder collaboration, as said, is at the very core of the success of all these different sectors, all these different processes going on. And what makes the stakeholder engagement critical to our success is the localized insights, ensure tailored and applicable and effective solutions from the different parts of Precilience. Also, engagement fosters trust. When we empower stakeholders, they are more likely to take up the solutions that we provide, and also commitment to the implementation. And also understanding the context in which the change to land use practices is being proposed ensures applicability and may lead to incentives or win-win situations for different stakeholders, such as landowners, industries, finance sectors, and authorities as well. So landowners are not the only, are at the very core of the stakeholder collaborations, but not the only stakeholders that we need for the successful uptake of the solutions. We need also finance sector, industry, and both local and national authorities. Thank you very much. And then, of course, anyone in the audience wanting to know how to get in touch with us or how to get more information about how to get involved with Precilience, please visit our webpage and follow us on LinkedIn or send us an email to the email address on the screen. We're very happy to provide you more information of the upcoming events, such as the interviews and workshops.
Thank you very much, Paloma. So now you have heard all about how we will use science to help food and forest production in changing conditions. Or perhaps we didn't tell absolutely everything. So as Paloma said, you can read more and contact us with those channels, but we have also a chance for questions and answers. So I will hand over to our communications manager, Naomi Pople. Please, Naomi, what kind of questions you have sent to us?
Thank you very much, and thank you to all our speakers for distilling sort of a very, very vast and complex project into just a few slides. It's quite a challenging thing to do, so thank you all, and thank you all for doing the important work that you're doing. And it's going to be an excellent project, which is running for the next 4 years. So there are plenty of opportunities to get involved, whether it's now, in 2 years' time, or in 4 years' time. So do please save those details that are on the screen now. You can get in touch with us at any time throughout the project. So some questions we've had in the chat. This one is for Jürgen. You mentioned continuous cover forestry in your presentation and stated that current policies are promoting it. Could you briefly explain what continuous cover forestry is and what risks might be associated with its implementation?
Yes, thank you for this question. I try to open up this topic a bit. As we know, the current situation is that our forests are mostly managed with clear-cut approach here in Nordic countries. However, this CCF or continuous cover forestry is really seen as a nature-friendly or more nature-friendly solution to forest management. So what the CCF means, first of all, we must understand that in each partner country, which we have here in project, CCF means a bit different thing or different approach in forest depending on local conditions and traditions. So the CCF means that we go to forest from time to time, let's say 10, 15 years. We harvest some trees or we harvest the small caps into forest. So it means when we take the lifespan of forest, we go there quite often. And by doing that, we create fresh stumps and damage the remaining trees. So, but this helps to spread different diseases, including heterobasidion or root rot, which is one of the most important diseases in our forests for conifers. So in theory, the CCF looks very good. We take only some trees, the remaining trees keep growing, and the new young trees are emerging naturally. But actually, yes, there are many problems, as I said, about the main concern is forest health. And of course, with forest health, if forests are in bad conditions, so it means that the productivity declines as well. So if productivity goes down, the carbon sequestration ability goes down. So, so to say, in long term, we might be in a situation where our forests are unhealthy and they don't grow fast enough. So let's say, it jeopardizes the sustainability of our forests in terms of productivity, and we may reach to a situation where we are in danger that we don't have enough timber, quality timber. So these are questions which are related to CCF in wider scale, and I think these problems should really be addressed before making any large decision or very, let's say, big decisions which impact all the forest owners. I hope I answered your question.
Thank you, Jürgen. I don't know if any other panelists have any further contributions to make. No. Actually, something that might be helpful, Jürgen, is how do you know what's the difference between a healthy forest and an unhealthy forest? What is it that you're looking for in a healthy forest? You mentioned sort of growth rate. What might be the, I suppose, lack of disease? What are the other things that you would consider a healthy forest?
There are diseases in every forest ecosystem, but the question is what's the proportion of these diseases, or what's the proportion of let's say, unhealthy trees? Different diseases are normal or natural part of forest ecosystem, of course, yes. But if there are too many of them, or if there are, let's say, mass outbreaks of bark beetles, there's a massive dying of large trees. So it means forest is unhealthy. So it means very simply that trees won't grow anymore. So we don't have any possibility to get the timber out of forest, and of course a large number of different forest ecosystem services are under threat, or we may lose them, including recreative values, carbon, as I already mentioned, and so on and so on. So it's a very complex issue, not only the timber, but all the other forest values as well.
Yes, gosh. Well, thank you very much. And again, just to reiterate, if you are a forester or you are connected with forests in the region in any way, do please get in touch. We desperately need to hear from you and get your involvement and buy-in. Thank you. A question for Davide. So you managed to quite beautifully explain something very complex in terms of data modeling for future scenarios, looking at adaptation versus business as usual. Can you sort of say what sort of data, what data are you collecting to take the measurements, and what data points are you looking at to compare business as usual versus adaptation? Precipitation, for example, disease occurrence, yields. That would be great. Thank you.
Yeah, that's try to simplify some concept, and I can expand a bit more now indeed. So again, giving an example on the agricultural domain, just to keep it on one side, but the biophysical processes is the same for the other sectors that we're looking at. But in agriculture, to run those biophysical models, because of course, when we look into the future, we're looking into future projection, and we need to simulate those weather, soil, crop management interaction in time and space. Now, those type of biophysical model requires input. As input, we need climate data, soil data, plant data. Then we do our calibration, our evaluation of those models based on experimental data. And then we run it and project the changes. So when we talk about business as usual, what it is, let's say, for example, a farmer plants a given genotype, a given wheat variety with a given agronomic management. We can then say, okay, imagine a farmer can experiment this type of management, whatever he does for this growing season, and he keeps doing the same. So imagine having an experiment where the only thing I can change is the climate and everything stays the same. We can then evaluate what is the impact of our climate variability on our given management. And that is not possible to do unless you do it in controlled condition where you can control your input and your climate, like in the glasshouse, for example, to some extent. It's possible with this biophysical model. It's quite robust for the science behind. It's been done a lot of time for a lot of different cropping systems in a lot of different scale, from point to regional to local. But those models require input and information about agronomic management to summarize everything. Therefore, that's why the point was it would be region and site specific first, with information that we feed from a specific location or a specific region. So that's the business as usual is what we are currently doing agronomically speaking from a crop management point of view. Then we can evaluate adaptation strategies. The simpler one we can think of, if we want to make a practical example, could be in the future is getting less colder in end of winter, maybe in some location, for example, in this hypothetical location, is getting less wetter in spring. Therefore, we could anticipate the planting date. That's an adaptation strategy. How does it work in the future and project the changes? So we can start evaluating all these biophysical changes given to some change in our agronomic management. I hope that clarifies a bit. I try to simplify some complex point, but that's the gist of it. We want to ultimately be able to tell stakeholder that's the impact of climate change on what you're doing. And if you adapt, that's the changes you're gonna get.
Thank you. That was very clear. Thank you very much. Anyone else in the panel? Further contributions? Oh, Mikko, yes, please. If you just unmute yourself for us.
Thanks. I always forget that. So yeah, I probably can like supplement David's reply from the VP1 perspective. So David really nicely put how these kind of like models will use and you apply bioclimatic data. So that's exactly like that. So they can like predict the production losses, for example, due to water scarcity or something like that. What we are doing in VP1 is that we are collecting information about pests and pathogens, and we are kind of like forecasting what sort of like future developments their abundances or presences might take in the future. So we can never say for sure how big impacts they will have for the plant growth, for example, but we can say that the probabilities of these risks are rising, and that is something to be concerned. And it might also affect the choices of crop species in the future. So that's something to supplement.
Thank you very much. I think we'll move over to Gian. Now there's a question for Gian, which is, what will the demonstration tool developed in the project look like? I suppose that's relating to your work package.
Yeah, yes, that's true. Thanks, Naomi. And so this demonstration tool will have a great emphasis on the visualization, because actually there are already many results in the literature and also in our other tasks that for assessing the impacts of this climate, this crop, soil and water management practices on yield production and soil health and nutrient losses, etc. But there, in my opinion, there's urgent need for showing the results in a better way to the farmers and also to other stakeholders like the regional authorities and those who work in the advisory service who give advices to the farmers, because the results, when we have results published in the papers, they are not so easy to be understandable by the general public and the farmers. But through the developing this kind of tool, we will focus on the to visualize the results. So what I'm thinking is that we will develop tool based on the landscape features. So we have, for example, we have a landscape map, and in this map there are fields with a high slope and fields with a low slope. And when we click on these different types of landscapes, and then when we add management practices, for example, cover crop, and then this tool can give results about the benefits of the cover crop in terms of improving or maintaining crop yield and reducing nutrient and soil losses. And on another kind of landscape, maybe it doesn't work that well. So by showing this to the farmers, then this will help the farmers to understand better about how these different management options work in different landscapes. And also we have experiments in different countries of the Nordic region. And then this also give us a range of different climates. So yeah, so in the end, this tool will help us to show under what kind of climate and the landscape and the soils this a certain kind of management option works better than in another situation.
Thank you so much, Diane. I'm conscious of time, so I think I'm going to hand us back to Petteri, but if there, of course, is anything else our panelists want to say that they haven't said, do please put your hand up and say so. Otherwise, Petteri, I will let you close the session for us, and thank you again to all of our speakers and you, Petteri, for chairing so wonderfully and coordinating this project for us.
Thanks, Naomi, and thank you all for presentations, participation in the webinar, and questions and all the helpful answers to the questions. Just a reminder, please follow us, share our posts and publications, this video potentially, and contact us when you are interested in our project. I'm really looking forward to all the collaborations in this exciting project and making change on climate adaptation. We stay in touch. Bye bye.